That's the best part.
Okay, welcome to chapter 4. So far, what have we done? Measurement and conversions, right? Chapter 1. Chapter 2. That was chapter 3. Good. And before percents was
Equations.
of lines. Good. So linear equations, solving equations, those kind of things. And what we did in chapter 2 with the 2 points and find the line, basically we're going to build off of that today, but we're going to have more than 2 points. Okay, so what we're doing is called, in chapter 4, it's called modeling, and what that is after collecting some data, trying to get a mathematical equation that fits that data. So then we can make predictions, because data isn't always fit nicely, so we try to average it out. So if you remember what we did on chapter 2 with Desmos, the Desmos.com, the graphing calculator, that's basically what we're doing today. But we're going to tie in also fitting a model that might be percentages, exponential functions. So, but the same process will follow. Okay, so there is this video here, Regression with Desmos. I think it's one I just found on YouTube that explains basically what we're doing today, how to set it up. So it's a little briefer, but I'm also recording what we're doing today. So we'll get there. Okay, so what I'm going to do is I'm just going to go, we'll start with an example from the textbook. So this is the PDF version, I don't know, chapter 4, example 1. If you want to follow along, you can go there. In here, they give instructions of how to use a TI 84 or 83 calculator. And the steps are kind of tedious and involved. I'm going to show you how you can do it with an online calculator, Desmos, and accomplish the same thing with much easier. So if you want to follow along, you're welcome to, and that might be helpful. If you don't, that's fine. You can watch, and then when we get to the quizzes, all the examples will be doing the same thing. Okay, so I go to Desmos.com, Desmos.com, and then I'm going to go to their graphing calculator. If you do Desmos.com/calculator, you get there in one step, so however you want to do it. Or you can have it downloaded on your phone. So there is an app that works with your phone. It'll all be the same thing. So just like in chapter 2, the first thing we do is what? Put in a table. Because we're going to give it the points, the data that we've collected, or that the book has collected for us. So I'm going to kind of make this screen a little bit smaller. So we have this data is a body's weight during a diet program. So someone's trying to lose some weight, and these are weeks, and their weight is going down, so it's being moderately successful. So we want to see how much that works. So what we'll do is we put the x values in as the top for x, and then, or they call them t, and the pound and weight will go in as y. So we've got 1, 2, 3, 4, 5. So I'm just going to enter 1, 2, 3, 4, 5. No, we don't need 6. Okay, so that's what we've got there. Actually, move this up a little bit, and we can, and then for the y values, we put in those 196, 192.
Wouldn't it be 192 for the first one?
Oh, thank you. Actually, they start with 0, not with 1.
Yeah.
Thank you. That's the biggest problem. Garbage in, garbage out. You can't get it right if you get it wrong in the front. So thank you. Let's change this to 0 and this to 1. I can delete that one. So 196 and then 192, and 2 is 193. There we go. Third week was 190. Fourth week, they didn't lose anything. That happens. And then the fifth week, they went down to 186. Okay. And over here, we see the points getting plotted, right? Well, we should, but we don't. Why don't we? Because our y values are up around 200, aren't they? And this graph only goes up to a little bit more than 4.
So you just zoom out.
We do, or and one way of doing that is coming to this. You can plus or minus, or you can, that's a nice thing with this, you can pinch in and out. But I also find that using this tool is very helpful because we know what values we have. We're only going from 0 to 5 for the x values, right? So I'll go from 0, maybe a little bit bigger, maybe 7, so we can see all the data. And our y values, certainly they're not going to get below 0 pounds. And if I go up to 200, I should have all my data included. So this is one step you want to do, is once you put your data in, make sure you can see it all by fitting the data there. And we can now see it. Here's the dots are all up there.
Oh, yeah.
I kind of like to see them a little bit better, so actually I'm going to go up to 250. And what that does is it sort of brings them down, because now the top of my graph goes to 250, and I can just see them a little bit better. Okay? Do those look like they're kind of on a line? Does it look like a line would be close to each of those? And yes, it does. Let's see. Actually, I'm going to go here. I'm going to get the line tool. So if I I look at this, I could probably draw a pretty good line like that. We could see that on this line, some of them are very close and some are further apart. And I could draw maybe a different line. The goal is to draw the line that is closest, that sort of averages it out, that's closest to all the points. And fortunately, that can be done with math. But it's very complicated math. It takes a line and figures out all the distance of all the points from that line, and then it draws another line. So it's kind of a long process that would be hard to do by hand. So what we're going to do is we're going to have the calculator do it for us. So I've got my table, I see my points. What I'm now going to do is I'm going to add an expression. And remember how I do this. So what are my variables? My variables are x1 and y1. Okay, so I want to reference x1 and y1. And since they're asking for a linear relationship, we're going to put in y1 equals, and do you remember what the linear equation was? Y equals mx plus b, where m was the slope or the rate of change, and again, last time we had it, we let it calculate it. X is our variable, but it's not just x, it's x1, right? And then the y-intercept, or the starting value, was b. And what happened to all my points here? Can't be defined in terms of each other. Oh.
I don't think the 1 is supposed to be in front of her.
It is, but it's not supposed to be equals. Remember, what do we put instead of equals? That squiggly thing, which is called a tilde, but I like to call it the squiggly. And again, you can get it from the keyboard if you're using the app or even this one, and it's down here on the bottom, that little squiggly. So that means approximately equal, because it's not actually equal, right? Because all the points are not on a line. But look, it just did all our homework for us. It's given us the equation, or at least it's giving us what m and b are, so that we could say, and oftentimes they want to know, and it's drawn the line. I did it so fast I didn't even recognize that. And notice some points are above the line, some are below it, some look like they're pretty close to being right on it. Okay, and that's what it is, but it's fitting the line. It's not, all these are not exactly on the line, but it's close. But we could say that this equation, y equals the m, which is minus 1 point, we'll call it 69. I'm going to round it to 2 decimal places. X plus 195.4. Okay, and they'll tell you what they want it rounded for. But that might be the answer to the question, is what linear equation fits this data the best? Okay, so we've got that. That's what it would, that's the best fitting data. And that's primarily what we're doing today, okay? But what we're also going to be asked to do is, so this was a 5-week program. You might think, well, what if this person was kept on it for, say, till 10 weeks, and they kept at the same rate? What would they weigh in 10 weeks? How could we figure that out? I'm going to show you how to do it. So what we're going to do is we're going to add one more expression, because to get this right in the Desmos, we need to use the rounded expression. So I'm going to put in this equation that I just got, that is the rounded equation, and I'm going to put y equals negative 1.69x plus 195.4. Okay, and now it's a red line. Notice it's very close to what we had. In fact, you can't even see that, the previous line. I'm going to turn the previous line off just so it doesn't get confusing. Okay, but now I've got this equation, and how would I figure out what happens in 10 weeks? Well, I was only going out for 7 weeks, so let's get out there for at least 10, maybe go for 12, right? So now I could come here, I could actually click here, and it will tell me when x equals 10, y is 178.5. Okay, so if the question was, what's their weight going to be in 10 weeks?
178.5.
That's what I got.
It's just
But it's again, you're getting close. Right there. 170, 10 gives us 178.5. Okay. Notice we can't tell it from here, but it's using this equation. We could also just plug in the 10 here and do it by hand if you wanted to, but this is a way to actually follow the graph and get the value. Okay, so the question might be, and we'll look at other questions that we go along the way. If x was 10, what is y? And we were able to look that up, and that's 178.5. Okay, and we just found that on the graph. Maybe this person has a goal. They started out at 196. Maybe they want to get down to 160. Get rid of that. How could we tell when they're going to get to 160? Another thing we could do, we add one more equation. We're going to put in y equals 160. So if they give us a y value, now notice we've got another line, this blue line, and all we've got to do is find where the two lines intersect. And it's not on our window, so what do? Stretch our window out. And what we're trying to stretch out is the number of weeks, right? Anyone have a good guess for how far do you think we need to go? 20 weeks. Again, if we went to 30, we'd probably see it too. 20 might very well work. Almost, it's almost getting there. Good. Yeah, so we want to be positive. So maybe go to 25 weeks or 30 weeks, and certainly at 25 we see it clearly.
All I did was minimize my equations, and the red line pointed down.
Well, it is pointing down, but it's you may have, again, if you change the windows significantly, it'll look differently. But then we just need to click here, and this is nice because it will keep it for us. So it's after so about 21 weeks. So you're pretty close there with the guess. We'll be down to 160. But notice how we take a little bit of data, we can fit a mathematical equation to it, or Desmos does it for us. We get the graph, and then now we can answer questions about, well, how long till I reach this weight? When I'm at this week, how much should I wait? Again, I didn't go on a binge or something, right, and maybe blow my diet, but if it were going to continue along this line, that's what this allows us to do. This is what they do, what researchers do. When they collect their data, okay, does this treatment gives us this result? They plot their data, they fit the best line, and then they can make their predictions based off that line. Exactly what we just did here. Questions? Okay, so that's the technique. I'm going to highlight a few things that we've got going on here as well. In what Desmos gave us with this part here, right? This is the important part. We've got to, and again, what we're basically going to do is we're going to leave this equation here because as we change the data, the line will change for us. So notice we've got the slope is given to us. The initial value, or the y-intercept, is given to us. And this other number here is what's going to be important. This R value. And what that R value is called a correlation coefficient. Don't try to say it too fast. Correlation coefficient. What it means, it's a number that tells us how closely those points fit to the line. And notice this is pretty close. It's negative because the line is going down, as you said. You know, it is going down. And if we, it would look like it's going steeper if we zoomed in on it. So it's going down, and that's where the negative means. And the fact that this number, 0.9354, it's very close to 1, means that the points fit the line very, very good. If it was a perfect fit and it was going down, it would be -1. R value would be -1. Perfect fit. And not anything that's less gets closer to 0. 0 would be like not even a line, maybe just a mess of dots. Okay. So R is a number that will always be greater than or equal to -1. Again, -1 is a perfect fit downwards, or less than or equal to +1. +1 would be a perfect fit, but going up. And it doesn't have anything to do with the steepness, just that the closer it is to 1, the closer each of those points are to that line. And we'll look at a few others as we do. As those points get further from the line, the R value becomes smaller, closer to 0. Okay, and those are really the 2 questions you're going to get asked, or 3 questions. You're going to be given some data, asked to get the equation, just like we did, and we found it. That's what we found up here. Secondly, you will either be given an X value and asked to find the Y value, or you'll be given a Y value and asked to find the X value. We did both of those by either tracing along this line or drawing the Y equals the value we want and finding the intersection. Yes?
During the quizzes or the tests, will we have to draw the graph ourselves? Like, show that we know
No.
how to do that?
You just need to be able to use the tool
Okay.
and then
Because
provide the
that
answers.
confuses the crap out of me, so.
Well,
I can do the equation, but as far
Right.
as the graph goes.
well, yeah. So just being able to use it though and we'll do this through a number of examples, and then as you go through the homework, it'll become, it's one of those things that once you catch on, it's, oh, this is easy. But yeah, there's a lot of moving parts right now. We're going to put it all together multiple times. But basically, this is the whole lesson. Okay. And then the other questions they'll ask is, what is the best fitting line? And that's what we use this R for. The closer, and all you have to remember, the closer it is to 1 or -1, depending upon whether it's going up or whether it's going down. -1 if it goes down, +1 if it goes up. The closer it is to those, the better fit it is. Okay, and we're going to see, because they're going to ask us they're going to give us some data, and they're going to say, is the exponential a better fit or is the line a better fit? And remember, exponential gives us a curve, so we're going to be able to do all of that. Okay, but I just want you to see all that's there. But that's basically all we need to know. And now we're set and ready. Let me get rid of this one because we won't be needing it. We will need this one, and actually we won't need that one. So this will give us our general. We'll be able to plot points. We've got our table set. Again, I'm signed in. If you want to save this if you're signed in, or if you've got the app, I think it'll save it for you. And you could just call this chapter 4 homework. That's what you're going to be using it for, or whatever you want to call it. It's up to you. Okay, and I'm going to show you how we're actually able to do all the homework problems with this. But I'm going to, let's see, let's get to one other example. Okay, so here's a U-try problem. And again, they just say consider the data set below. They don't tell us what this data is, but all we have to do is first enter it in. And so set your table up. So they've got 0. See if I haven't found a good way to clear out a table. You can delete it, but since we've got everything else set up, so it's 1, 2, 4, 6, 8, 10, and 12. So I like to put the x values in first, and then come over and put the y values in. 23.76, 24.78, 25.93, 26.24, and that's 6. Okay, and make sure I'm on track. I sometimes get off on this, and again, if I make an error of input, I'll get it wrong. Even a little error, like this, 27 comma, that's not going to work. 27.04 and 27.93. Okay, so I've got all my data in there. I don't see it over here. Oh, there it is. But it's somewhere, it's between 0 and 30, right? I don't need to go up as high. So I can reset my window. I don't need to go to 250. So maybe I go to 40. And I'm only going to 12, so I don't need to go to 25. If I, again, just want to see better, maybe I'll go to 15. Again, it's all however you want to fit it, but just as long as you can see all your data. Now, does that data look like it's like it could follow a line? Yeah, but we could see it's also not a perfect line. How do we get the line to fit? Well, we've already got it here. That's the nice thing, is the second time we go to do this, all I got to do is turn on my regression machine, because I turned it off. As soon as I turn it back on, there it is. And if you want, at least on the computer version, you can click and hold if you want to change the color of the line to make it prettier or whatever. You could do that. Okay.
And I'm sorry, how do you turn on the regression line?
For me, if you've already got it there, I just click on this button next to it. It turns it on and off. On the app, it may work a little differently.
You just tap it.
You just tap it, okay, so you can turn it on and off.
You just tap it once to turn it off, tap it again to turn it back.
Okay, there you go. And now notice the R value has changed a bit. It's 9.97. The last one was like 0.98. So this doesn't fit quite as good as the last bit of data we did. And it's also getting close to a positive one because it's going up instead of going down. And you can see that in the data. What would be the equation if they were asking what's the best fitting equation? Best fitting equation comes from these parts right here, right?
Yep.
Y equals 0.322. Oftentimes they want 3 decimal places. I rounded the 1 up because there's a 9 next to it. X plus 24.16.
Of course, we use the tilde for the equals, right?
Well, when we
right.
give the answer, we'll actually use the equal.
Okay, right.
Desmos only uses the tilde thing because that tells it to calculate it.
Right.
Okay, so so up here, the only place you're going to ever, put this is when you're using decimals. When you go into our homework system and it asks for the equation, you're going to use equals. And again, it's easy to forget one way or the other. And so when you're having that, just say, oh yeah, I'm supposed to use the equal sign here. Over here, I'm supposed to use the tilde thing. And I forget myself, okay? And it might ask it might ask for this R value. So that's right there. It's telling how closely the points fit. And what I'll do is I'm just gonna show this to you. Not that you would do this for any reason, but if we change one of these X values, let me change this one to be, I'm gonna make it be further away. So I'm gonna make it 15. And notice how the line itself has all changed to kind of bring that point in. And the R values changed significantly. Actually, it's now going down, so that one piece of data, if I make an error, I get a completely different thing. Okay, so that's the thing to watch out for, is you could have everything entered correctly, but one error on this, it's all off. And the thing is, a big error like that, you might spot it, but if you made a smaller error, sometimes you wouldn't see it. And I'll go back. What were we at? Let's see. 10 was actually 27.04. And now we see it back to what it was. Okay, we see these values right back. Okay, but that's going to be the homework. So are we ready to jump into the quiz?
Might as well.
Okay,
Yeah.
and I'll show you that this is all. Now there's still one thing left to learn, and that's about exponentials, but that's going to be, I thought, let's just do it when we get there. Okay, so let's go over here. We'll go into the quiz.
Same thing, questions are structured the same, just the values are different.
Right. So use linear regression to find this equation. Again, all we have to do is enter this. What I'll do is I'll make it a little smaller this way. And I'll bring Desmos over here. So the first step is and if you follow the instructions that they give, if you're using a TI calculator, they're really pretty much the same. You put your data in first. So I'm going to put in 1, 2, 3, 4, 5, and 6. They don't have a 12, so I'll just hit delete to get rid of that last piece of data. I then go in and put my Y values in. 481, 2697, 7137, 13,538, 24,797, and then finally 36,563. I mean, your numbers may be different. Are they, or are they the same?
They're different.
They're different. Of course, they have to be.
I'm not even doing the quiz. I always wait till after to.
That's fine. That's fine. So we've got our data in. Let's go ahead and make this full screen now. So we don't see much, although it's fit the line for us. It tells us what it is. But to be able to see what we've got, we just kind of, okay, we're going from 1 to 6, so x 1 to 15 is okay. But we get up as high as 36,000, so maybe 40,000 for our y. So instead of going to 40, let's go to 40,000. And all of a sudden, we now see all the data. And that line does kind of average it out. It fits it. And so what we want to do, though, see if I can go back and forth.
Go to 2 decimal places.
They wanted it to 2 decimal places. Okay. So let's bring it a little slower. This is the part we need here. Round to 2 decimal places. So when we're going to put it in, what do I put in for the slope?
So for the slope, that would be 7231.74x.
Exactly.
Or in my case, because it's different, mine would be 8.69x.
Right. And then the minus,
Wait, why would it be minus?
because the b value is negative.
Oh.
You could put plus or minus, but I don't think it would like it for 11,108.9.
Okay, minus it.
Now, the one thing I find is sometimes when we go to, this is giving a rounded value, so I'm going to check the answer. It still gets usually close enough. So the system had a 0.93. We only have 0.9 that it gives us, so it's as accurate as we can get it. Okay? So they asked for the equation. Desmos is going to give us the equation. We enter it in, and again, if you have some difficulties, a lot of times it might just be a rounding, because again, I was noticing they asked us to round to 2 decimal places. B's only giving us 1 decimal place, so it could be a rounding issue, and there's no really easy way to fix that. Question 2. Now this is where we're going to need to get the equation, and then they're going to ask us for some, if x is this, what is y? So they're going to ask us a few more questions, so we'll see how to answer those. But again, what you'll see is to do the homework, all I got to do is, I'm all set up, I just need to put the new values in. Okay, so again, we've got 1, and we go to 3, 7, 12, 14, and 19. Then you put in your y values. 6, 7, 2, 3, 7, 2, 2, 1.62. And yes, you do have to enter all the decimals and all the points. 10,584.28. 10,922 and 11,910.15. Okay, so once we're set up, notice there's not a lot of paper pencil work to do. It's just done it. And then since we have our line turned on, it's already done it for us. And notice we're only going up to 12,000, so we actually do see all the points here. So I'll just make it larger. Or, so you can zoom in, zoom out as at your will, or you can always come back here and say, oh, I only want to go from zero to 15,000, and I'll still be able to see it. Again, the fit, you can make any fit you want. But that fits pretty good. We can see it. We've got our R value. We've got our equation here. So let's go see what the questions are. Again, our stuff is right here. The question is, based on this regression model, the value of this investment was blank in the year 1996. So they're saying this is in years after 1996. So 1996 would be the beginning year. Now, based on the regression model, they're not saying based on here, which actually they didn't give it to us anyway, what would be the value of the investment in the first year, or at the start? The initial value.
6,000.
Good. That's our B value, the y-intercept. That's our initial value. That's our starting value. That's our y-intercept. So it's giving it to us $6,491.60. So when we have that value, we've got our answer, 6491.60. Okay, and I'll click on the answer thing, and that's what it gives us. So good. Second question. Based on this regression model, the value of this investment is it increasing or is it decreasing?
Increasing.
It's increasing, which means going up. At a rate of what per year? Where do we find the rate in an equation?
The R?
The R is telling us how good of a fit the line is to the points.
B.
B is the initial value.
0.2.
Y equals
Oh.
mx. It's the m. M is our rate
Oh.
because we're multiplying by it. So it's changing. It's the slope. And so what this is telling us is that this investment is increasing about $304 a year. Right? So it's increasing 304.87 if we round it to the nearest cent. 304.87. And let's see if that's what they went to 86, so they didn't round it. Or in their model, maybe, so this is what I mean. Sometimes this is based off, an unrounded. So sometimes if I went 8.7, they might count it right. I'm not sure. Let's see. What if I go 8.7? Because I can do this multiple times. No, they counted it wrong. So sometimes I would say, oh, I rounded it. Maybe I shouldn't have rounded. Okay. So, but if you have problems with this, if you're that close, we're going to count you right. Because that's what I would actually do, is I would round it based upon what I was given as being more accurate. So far, so good? Okay. So basically, they asked for the equation, but we just had to enter those things in differently.
Oh, wait, hold on, that's the wrong answer, what is it?
Well, it was 304.86.
Oh, okay.
They didn't round, and
Oh,
that's what I
okay.
had in.
Oh, okay, so.
Yeah. I would have rounded. I would have got it wrong the first time, and then I said, okay, let me try it without rounding. Oh, that's just part of the problem we have here. So this is a concept question.
So that means the quiz is wrong in this case since they didn't round up, right?
I would say so.
I
would say so, yes. So question 3 is a concept type question. So thinking of what R means, which of these values shows the stronger relationship. And when they say stronger, it means that which one would have, the points would be closer to the line.
0.2.
What are we looking for? What value? What is this?
Would it be negative 0.1? Because, like, it's a smaller number, so they have to be closer, right?
If they're closer to, what did I say? If it was close to 0, it means there is no relationship.
Oh, okay, so.
What do they want to be close to?
Wouldn't it be 0.5 then? Because that's the furthest away from 0, so.
It
Well,
would be negative 0.8.
there you go.
Furthest.
It's,
Oh, that's true.
so we're looking which one is the furthest from 0, also which one's closest to either -1 or +1. Now -8 or negative
Closest to
-0.8 is
-1.
closest to -1, which means it's a decreasing, but it's also the strongest, it's the indication of a strongest relation. The points would be closest to that line than any of the others. But yes, 0.5 would be next in line for it. But they just want one right answer. This is going to be the strongest. So the strongest one's always the one that's closer to either -1 or 1. Now, if they had -0.8 and they had +0.9, which one would do it? +0.9. So it's not about whether it's negative or positive, just which one's closest to 1. Okay, and we'll check our answer, and yes, that's right. Yeah, so it's kind of just, and again, that shows up here. We could have looked, oh, these lines, these dots are pretty close. That's a 0.99, so that's what that R value it gives us means.
We're looking at example number 5
Yeah?
on the thing, and I'm so confused. It's okay. I'll figure it out. I always
Okay.
do.
And that's really what it is yeah, if confusion is a good sign, it means that you don't know everything, but then working through it, you'll get through the confusion. Okay, so the last 2 are now, so at least number 4, we've got 4 and 5, so there's only 5 questions. This last one's asking for an exponential regression, which we didn't cover, but let's cover it now. Okay, so we've got one set up for linear regression. I'm going to set up a new one, and this is one that you can, again, and I'm going to turn off I'll leave it on for now, but we want one that will give us an exponential regression. So what's an exponential function? Well, it's y equals the starting value, which they called a, b raised to the x power. So actually we do that, but not equals, right? We need that little squiggly.
What's the
What is it called again? Yeah.
The tilde
Tilde.
is the official name. I don't know where that comes from, but
Maybe
I had to
it's
look
Greek.
it up, or something, yeah,
It's usually Greek if it's math.
or Latin. Well, yeah, but yeah, it's in math. They call it the approximation symbol. So anyway, notice that just by having this here, we now have a green curve. It's taken the data and it's actually a curve. It's not a straight line anymore, right? Because it says this data is exponential, so let's fit the best exponential we can through it. And notice these numbers right here give us what our equation would be. It would be y equals a 6827.95. Usually b we put in a parentheses, 1.03, I'll round that to 2, raised to the x power.
I can't find the function to put it, to get that x1 on the top there. Tangent in the calculator, I mean.
Which one?
It's an exponent.
Right here.
Is the exponent?
You click right here.
Oh, alright.
And then
Good,
Looks like, yeah.
cool. So be able to get the x1. Let's put that down. Okay, from those who have done Unit 3, looking at the base here, what would be the percent increase in this?
3.2%.
3.2%, right? So we're going to tie in some things we get from 3, because, right, if you turn this into a percentage, that's 103.2%. 100% is what we started with, so if we subtract that off, we're left that we're growing by 3.2%. Okay, for this particular example.
Can you keep this up for a second?
Sure.
Like longer. Sorry.
So with that equation, 6827.95, parentheses, 1.032 being the answer for like P equals or.
Well, if they ask for the equation, that's what we would
All
put
right,
in.
I got it down.
Good.
Yeah, they're asking for the equation.
So now, now that we've got it set up, we're ready to do question 4. So this, I was just applying it to previous data to show that it can be done. To do number 4, what we have to do is they want exponential regression. This is our data down here, so they give us some new data. What I'm going to do is I'm going to turn off the linear equation because they don't want that. So that won't show up. And now I just need to enter in my data. Again, the first step for all of these problems, enter in the data they give you. So 0, 3, 7, 12, 14, 19. It looks very similar to what they had before as far as the x values. The y values are different. 3,400.
Oh wait, just now what we did, was that part of problem 4 or no?
No.
Oh.
I was just getting the exponential regression set up. Now I put in the data that they gave us for number 4.
Oh, okay.
Yeah, we still had the data from the previous one. So again, it's just kind of enter in all the data, make sure it's accurate. Four nine nine 3.01, 5142.81, 5663.82. And actually, I just forgot, there's one thing, when we do the exponential regression, you want to have this button checked, log mode, to get the actual correct answer. Okay, and I don't know how to explain what it's, but the TI calculator uses log mode, but they don't give you this choice. For some reason, Desmos does it in kind of 2 modes, but you want it in log mode. Otherwise, your answers won't match what they have in more. Okay, so it says use your calculator to determine the exponential regression equation that models the set of data above, which we can see it here. Here's our data. We can see an exponential is fit to it now. It's a curve.
Question.
Yes.
So if I do use the T1 calculator, because that's what I've been trained to use my entire life, if I do use that one, the answers won't be correct?
No, they will be.
They will be, okay.
But this,
Got it,
but
okay.
by marking this,
Yes, the log mode.
then this will match also the TI.
Okay,
The TI, you don't have to do this extra step.
thank God. Okay, thank
Okay,
you.
but it'll fit the data, graph it. Okay. So what we get here is they want the equation. So again, and they're using not x and y, but n and capital P. So let's say P is equal to, and again, here's our details. Here's our A and our B. So we entered the A part, which is 3,412.47. We entered the B part, which is 1.0288. and we raise it, which is a shifted 6, it's that little chevron thing, to the n power, because that's what they use for that variable. And they rounded it to 29, which, well, they want 3 decimal places. Okay. Yeah. And then, just like I asked, based on the regression model, what is the percent increase per year? Just like that last question, right?
2.9%.
Right, so we subtract 1 from here, and we get 2.9%. Very good. Okay. Use your regression model to find p when n equals 15. Okay, and so again, this is a place where since we want the rounded model, we actually have to enter in the rounded equation. So we put in y equals 3412.47, 1.029 raised to the x power. I'm going to turn off the green one, so this is what we've got. And we want to figure out when n equals 15.
Wait, sorry, I have so much train of thought. How did you get the 2.9%?
Because the Desmos gave us 1.0288, and we rounded they only wanted 3 decimal places, so we rounded the 8 up to 9.
Okay, okay, so you went with 2 places, 2 places to the right, and then, okay, yeah, I see, yeah.
Okay, so now that we've got this, we can trace along here until we get to 15. Or another thing you can do, if you want to get it exactly, is you can put an expression and you can put in x equals 15. Now you can't do that with the TI calculator, but you can do it with this one, and you can click on it and we'll give you the exact value. When n is 15, this is going to be the value. So we can enter that one in. 5239.62, rounded to 2 decimal places. Let's see. Round your answers to 2 decimal places, because it's in thousands of people. And this is interpret your answer by completing the following sentence. The population of the town after how many years? 15, right? Because they asked us when n was 15. The population is 5,239.62.
So in my case, mine was 20, but
Right. So you may get different, but what we're getting over is how to use the tools to answer the questions. Okay. So
but I don't know where the line is. It's just going straight up, and I don't really see where they cross.
right. So you may need to set your window so that you can see everything.
What were your window settings?
And again, you base that off the data. So our data is going up to 6,000. So you should see at least up to 6,000. Goes up to 19, so the x's should go up to at least 20. Okay. And then that way you'll be able to see your data, and then you can click on it.
Just bring it up so I can see what you did, so I kind of understand how it works.
Just click on it. Yeah, so you should be able to, so I added x equals 15. and that gives me a vertical line at x equals 15, and that's where it intersects the equation that I entered.
It's just gonna slightly like these arrow symbols are not quite.
Okay, we can work on that. But yeah, what you're going to want to do is get your x-axis, and again, we're only going up to 20, so maybe you go to 25.
Excuse me, what was the answer to D on 4? Like,
And-
I didn't fully get it.
5,239.62.
39.62. Okay.
Right.
Thank you.
But again, focus on being able to use Desmos to do the regression. And whether we're doing exponential regression or linear regression, all we're going to need to do is change which equation we're using, right? So if you save your Desmos with one or these two, you'll be able to turn on the one you want. If they want linear, you turn on the linear. If they want exponential, you turn on the exponential.
Oh, okay, good to know.
Okay. And then when they're wanting us to solve, we actually enter in the rounded equation. Otherwise, you'll have a different level of accuracy than they're requesting. Okay? And number 5 is basically the same thing with different data. Exponential, find the equation, but then they also want you to find the linear. So that's why if we have them both in here, I'm going to take these old ones out. Once we put in our new data, we'll get both answers. We'll get the exponential from this top equation, the green one. The red one will give us the linear equation simultaneously. And that's what the TI-84 can't do, but you can do it in 2 steps. Okay, you put your data in once, and then you do the calculation on those. So I can help you with those.
That would be great.
Yeah. Okay, but again, we have to put our data in. $6.99, $9.21, $13.12, $17.11, $21.44, and $27.92. So we've got all our data in.
Okay, I got it now.
And again, I always like to fit the data pretty well, so we're just going from 1 to 6. So maybe if I just have my window, my x's go from 0 to 10.
So the population of the town after, in this case, was it 15 for your one? After 15 years is.
Yeah.
Can you go back so I can see what you did, just so I can know what I'm doing?
Well, we're on to the next problem. So,
Okay,
but
alright,
I can help you with that. Yeah.
I'll just fill it out like that.
So this is showing us the equation, the dots, and yes, it could be exponential or it could be linear. So they give us the equations here. The first one is exponential, second one is linear, right? So we just, for the last one, you just have to make sure they wanted exponential first. So we're going to take off of here. Here's our A, so it's y equals value for A, 541. They want 2 decimal places, so that's going to be 0.7. The 9 gets rounded up. When the 9 gets rounded up, what happens to the next number?
Also get rounded
It
up.
also gets rounded up, so I would round that to 541.80. The B value is 1.32, rounded to 2 decimal places, so that's a 32% increase, right? Raised to the x power. And then they want us to put the linear equation And again, from the same window, we're able to go to the y equals mx plus b. So y equals 415.23, rounded to 2 decimal places, x plus 143.2. So that's the equation there. Now it's asking which of these two equations fits the data best. So this is where I want to come back and highlight this R value. Which one of these R values is closest to 1?
The second one.
0.98,
The first one.
0.99. Yeah, so it's just a little, they're both a good fit, but I would say the exponential is the better fit because the R value is closer to 1, a little bit closer to 1. And again, this is sometimes I've seen these, where these questions might mark it wrong, but I mean, that's what I'm going by. So we'll see. Check our answer. It is. But that's what we're checking. We check that R value. The one that was closer to 1 would be the better fit. Okay. And that's the extent of the types of homework. Again, you're going to be given data, asked to do the regression, get a straight line, also do the regression, then they'll ask for the exponential.
Yeah. Is there anyone to look back at number 4 just so?
Okay, we'll just, when we finish up.
Yeah.
Any questions? Ready to head in? Okay. And again, if you want to see how Desmos does it, there's a shorter video that just shows the details, but it's get it set up and then have that table, and you're just continually changing the table. The specifics of the questions we can also discuss. All right.